Assalamu alaikum warahmatullah, students. Hope you'll be fine. I am Mr. Tariq in the subject of physics class is 12th. We are in the unit of current electricity as you know. Today we have started the topic. It is the relation between drift velocity and current. We discussed the drift velocity in the previous topic. Now we are here. Okay. See here we have taken the conductor of length L. It is connected with battery. Okay. This we know there are free electrons moving in the conductors, metallic conductors. You should know they are those conductors which are in solid form, like iron rod, copper, etc. Okay, so here the current is due to free electrons, not due to free atoms or ions, but only due to free electrons, because free electrons easily move through the gaps between the atoms, so they constitute the current when battery is connected. Now this time we are going to discuss relation between the drift velocity and current. Let me repeat about the drift velocity. Drift velocity, you know, it is the average velocity with which the electrons move from one end to the next end by applying battery or by applying electric field, right? So now let us start. So here it is, consider a conductor of length L and area of cross section A. This is the area of cross section. Let me show you here, like if this is the conductor with length L, okay, and area of cross section used to be this area. Okay, so this area is the area of cross section. Okay, so here it is area of cross section A. Let n is the total number of free electrons per unit volume. In the unit volume there are n number of electrons. Okay, then total number of n is number of electrons in the part. What part? In the unit part volume. Okay, then how many electrons will be in whole of it? That will be equal to, here I have written total number of electrons in whole conductor, in all of it. It will be per unit volume electrons into volume. How much is it? Is volume, it if it is volume is more, number of electrons will be more. It is volume is less, number of electrons will be less. Now so I may write here it is equal to n, right? So how we represent volume of the circular, let it be circular conductor. It is volume used to be length into area of cross section. For the circular conductor, it is volume used to be, it is length into area. Okay, so this is the total number of electrons in whole conductor, right? See here, now let E is the charge of electron, and we know I have written here magnitude of E, or we say plus E, because I am discussing here only magnitude, not plus or minus. So for each electron charge is E, then what will be the total charge in it? That will be simply what is the total number of electrons in it into charge of each electron. So that will be given by this. So this Q NLA into E will be the total free charge due to electrons present in whole of the conductor. Now next point here is how much time a free electron will take to cross whole of the conductor, meaning from this point to this I have written time taken by free electron to cross the length of the conductor, that is given by T is equal to L by Vd. How this relation comes? We know velocity is equal to length over time. Okay, or we say it is displacement over time, but here displacement is simply the length of this. Okay, so I can repeat velocity here will be denoted by Vd is equal to length be L divided by time T. Then this T is here and it will come to this by cross multiplication, so we will get this relation. So this is the relation which we got it. Let it be equation number first. This is equation number 2. Now next relation also we know that See, we know the definition of current. I is equal to Q over T. Okay, this is the definition of current, charge per unit time. We are discussing now the charge of whole conductor, right? Or I mean, right? Or this IT is equal to Q. Now here is the value of Q and here is value of T. Use the value of Q and this in this equation, equation 3. I will write using first and second in this equation number 3. We get here it is value of I is Qt, sorry, it is value of I is equal to Q over T. Okay, and it is on time T. Sorry, it is something different. We have to use this and this equation in this. See, I is here and T is here, so I is like this and value of T, it is L over Vd is equal to, this is I and this is the value of T over here, then is equal to Q. What's the value of Q over here? Q is equal to NLA into small e. This small e is the charge of free electron. And this L and this L gets cancelled out. We'll get I is equal to NEA and this goes here Vd. This is NEA and Vd. So this is the relation between drift velocity and current. This is drift velocity and here it is current. Okay, or I may write Vd, sorry, yes, Vd is equal to I over NEA. Vd is equal to I, this will come down. So here it is clear that drift velocity is directly proportional to current. More the current, more will be drift velocity, but if area of cross section will be more, drift velocity will be less, right? So we may write, I may write n and this number of charges, free electrons per unit volume, and charge of the free charge is constant, so it will be Vd is directly proportional to current because these factors are constant. So if you are going to increase the drift velocity, you will have to increase current, or if you are going to increase the current, you will have to increase the drift velocity. Now here is the next topic. It is mobility of electrons represented by mu e, and it is relation with current. Okay, see, mu e is defined as drift velocity per unit electric field. Drift velocity of electrons per unit electric field. Okay, or we may write mu Vd is equal to mu into E, right? So here we know relation between current and drift velocity is this. I may write here, we know that what's the relation of current and drift velocity? That's I is called NEA Vd. You should memorize this relation, right? Use here the relation. I use this relation in this equation. Using first and second, we get I is equal to NEA Vd. Here Vd value is mu E into electric field, right? So this is the relation between current and mobility of electrons, and it is SI unit of mobility is meter square per second per volt, and this. Okay, so this was all about the relation of drift velocity with the current. Okay, so here we got two important relations. First one is I is called NEA Vd, next one I is called NEA mu E into electric field. This was all about drift velocity, and in next topic we will take some numerical problems, and then after we will discuss Ohm's law. Hope you are good, you are fine, and you would have got the points. Okay, then thank you. Assalamu alaikum.